Okay, so here we want to try to compute the derivative of the function b to the x. So this is our general exponential function. And so what we're going to do is just use our limit definition. So writing this down, we would get b to the x plus h minus b to the x over h. And so I'm going to use my exponent law to rewrite this b to the x plus h as b to the x times b to the h. Right, so that is just from one of our exponent laws. Okay, and now I have b to the x in both terms in the numerator, so I can go ahead and pull that out. So factor it, and I would get b to the h minus 1 over h. And now, so what happens here is that b to the x is a constant with respect to this limit. And it is a constant because it doesn't involve any h's. And h is what we are taking to 0. So h is what is approaching some number. So it's sort of the variable of our limit, right? And so b to the x, since it doesn't depend on h, is a constant as far as this limit is concerned. So we can actually pull this out of the limit. So it's not affecting how the limit is going to be evaluated in any way. Okay, so what we would be left with inside of the limit is b to the h minus 1 over h, right? And now we don't have a way of evaluating this right away, but we can find the value of this for a certain value of b. Okay, so first thing is to note that f prime of 0, if we just want to evaluate the derivative at 0, this is equal to the limit as h goes to 0 of b to the 0 plus h minus b to the 0 over h. And if we simplify this, we would get just b to the h minus b to the 0 will simplify to 1. So this is actually the same limit as what we have right here. Okay, so what that means is that, or here, let me write it this way. This means that f prime of x is equal to b to the x times f prime of 0, right? Because that's what this limit is equal to, so I'm just replacing that with the expression f prime of 0. So I'm going to write that f prime of 0 times b to the x, like that. Okay, so this might seem like a redundant definition, and it is because we need the value of the derivative at a point to define the derivative, right? But it happens that there's a particular case in which we know the value of this limit. So we would know f prime of 0. And that case is when b, the base, is equal to e. So one of several equivalent definitions of the number e so Euler's number e is that e is the unique number or such that this limit, so the limit as h goes to 0 of e to the h minus 1 over h is equal to 1. Okay, and so this means that we know the value of this limit that we want to use to define the derivative only when we have e. So in that case, and it's really part of the definition of this number. Okay, so what that means is that if g of x is e to the x, then the derivative g prime of x is, from before we have f prime of 0, so that would be g prime of 0, which we know is equal to 1 times b to, or sorry, in this case it would be e to the x. So we get that the derivative is just e to the x. And just to write this in a different way, that means that the derivative of the function e to the x is equal to e to the x. So notice that this is saying that the derivative of this function is equal to the function. And this is the only function that has this property. This is the only function that is equal to its derivative. Okay. And so what this means is that at any point, how fast e to the x is growing is equal to the value of the function at that point. Okay, so right now we can't calculate the derivative of b to the x for any other values of b, but we will be able to do this later on. Okay, so so far what we have in our library of derivatives is, so for a constant function, the derivative is equal to 0. For the function f of x equals x, the derivative is equal to 1. If we have x to any power, where n is not equal to 0, so remember that we exclude that case, then we use the power rule, and this would say the derivative is n times x to the n minus 1. And then our last derivative that we can calculate is e to the x, and we saw that that is the derivative of that is just e to the x. Okay, and so we will be adding more functions to this as we go along, but these are the ones that you should know right now. Okay, and so don't forget to do the comprehension check question. Okay.